Good morning. So myself, Dr. Maheswara Rao, Assistant Professor, Institute of Aeronautical Engineering, Department of Civil Engineering. Today we are going to deal the course name is Fluid Mechanics and the topic name is Surface Tension. The course outcomes are, at the end of this course, students can define the fluids and their properties, and also Newton's law of viscosity. So what is the Newton's law of viscosity and the problems related to that? So those are the course outcome 1 and course outcome 2. So definition of the fluids and properties and what is the surface tension. So this will come under the course outcome 1, and the Newton's law of viscosity and the problems, related problems, will come under the course outcome 2. In case of course outcome 3, so what is the capillarity rise or what is capillarity fall for a small given tube? That is the course outcome 3. And course outcome 4 is the concept of surface tension and their applications. Course outcome 5 is the capillarity and the compressibility. Course outcome 6 is the flow of fluids in a pipe. So pipe flow and how this pressure varies from one point to another point after traveling a certain distance. So due to friction. So that is the course outcome 6. Today we are going to deal with the surface tension. So you can see the line here. This effect causes the liquid surface to behave like a very thin membrane. So here, very thin membrane, it will act like that. So effect of surface tension is that. The surface tension is defined as the force per unit length. It is nothing but the force per a unit length. Units are Newton per meter. So here, before going to that, so why this water droplet is spherical? So spherical means like this. So why water droplet will be like that? Why not rectangular shape and etc. Here, basically, water is made up of two things here, two elements. What is that? Oxygen and hydrogen. Here, the oxygen is having negative and hydrogen is positive. So this will attract each other. So this will have attraction, molecular attraction or elements attraction here. So that one oxygen element will attract the two hydrogen. That's why it is H2O. So that means if oxygen is here, then it attracts H and it attracts another H also. Okay, this is oxygen. So one oxygen will attract two hydrogens. That's why a molecule is formed, which is called H2O. It is nothing but the water molecule. And here the thing is that why this water droplet? See, droplet is different. Okay, droplet is nothing but the combination of so many molecules. So these molecules will form, that means a droplet will form a spherical shape. Why? Why not this rectangular or any other shape? We will see that. See, this is one water molecule. This is another water molecule. So this will have oxygen will have negative attraction and polarity, and then hydrogen will have positive. So in addition to these hydrogen molecules, so this molecule and molecule will have attraction. Okay, so this positive and negative. So what will happen? All the molecules try to come closer. So that's why we can see the water droplet is a spherical in shape. So we can say this. So in the body of the liquid, a molecule is surrounded by the other molecules. Here, one molecule is there, it is surrounded by the other molecules. So and intermolecular forces are symmetrical in equilibrium. So you can see here, this is one molecule, this is another molecule, this is another molecule, this is another molecule, this is another molecule. Like this, there will be a attraction between the molecules, which is called here intermolecular forces. Okay. So because of this intermolecular forces, this you can see here, it is a symmetrical and an equilibrium. So that's why the droplet is in a spherical shape. So you can see this. At the surface of the liquid, molecule has the force acting only through 180 degrees. Here, the force of acting is only through 180 degrees. That means it is a straight line. Where is the straight line? It is at the surface of the liquid. So, if water is here, okay, at the surface it is a 180 degrees. What about inside the water? So, it will have same attraction in different directions with other molecules. But here, why it is straight line? That means here also water molecule will be there. So it will have attraction with this molecule. It will have attraction. It will have attraction. It is also having attraction, but here is no water. Here it is air. So that the attraction force here is negligible with the air molecule. So that it will attract the water molecules here in this direction. So that it will have 180 degrees at the surface of the water. Okay. So here the surface of molecules is being pulled inwards towards the bulk of the liquid. Okay. Here one molecule is attracted by the another molecule and also towards the inside of the liquid, bulk of the liquid. So you can see here H bond is strong attraction between water molecules. So that's why the water droplet will be attracted towards inside. So that's why it will have spherical in outside surface. You can see here. So actually water will have like this. So here the molecular attraction, here you can see the molecular attraction between the water molecules. So they will be attracted towards. So it will be formed like this. See here. So before attraction, it is like this. Having attraction and all upward attraction is becoming zero, so that all these molecules will be attracted. It will form a horizontal or in a straight line. So that's why it is a 180 degrees force. See here. So this is a water droplet. You can see this figure. This is a large amount of water. So it will have horizontal or 180 degrees force of action. But whereas in this figure droplet, you can see this will have attraction with the other molecules, and it will not have any other force at top side, because the other side is the air molecules. So it will have closure. It will be attracted towards each other. So to make it will have a lesser surface area, so that this water droplet will be formed in a spherical shape here. So you can see this. Liquid droplets behave like a small spherical balloons. Okay, at the surface, which liquids act like a stretched elastic membrane surface. So here, it will have a molecule will have surface tension here. A molecule inside the liquid will have forces equally in all other directions. Here, in upward direction is becoming zero, so that all other molecules will be attracted. So it will have a horizontal force, that means 180 degrees, which will have a small membrane under a tension. So the top surface will have some tension here, membrane tension. The pulling force that causes due to the attractive forces between the molecules is called as surface tension. What is the surface tension? It is nothing but the pulling force. So one molecule is there, another molecule is there. So this molecule will be attracted by this molecule. So intermolecular forces. That force due to the attraction of these intermolecular forces on the surface, so that is called the surface tension. Here the formula is there, F delta P. Okay. So here what is R capillary? It is a real fluid drop. R is the radius of the droplet. So if a droplet is here, okay, this is the radius. and sigma is the surface tension. So in the surface, it will have some tension here. So it is having at the surface of the droplet. So it is the sigma. Sigma is the surface tension. So delta P is the pressure difference between the inside and outside pressure. So here, inside some pressure will be there, outside surface tension is there. Okay. So delta P is the difference of inside pressure and outside pressure here. So whereas this pressure force is called the pi r square into delta P, where delta P is the difference between the internal pressure and the external pressure. So you can see this R is a radius of the droplet. Okay, here sigma, you can see here, it is a surface tension, it is available at the surface of the droplet. Okay, so this is the internal pressure, delta P pi r square. So this is acting in this direction and this acting towards internally. Okay, the force developed around the edge due to the surface tension along the line F sigma. So F sigma means here surface tension, that is equal to 2 pi r sigma. So surface tension means here. So here the force will act at the surface. So that force is nothing but 2 pi r sigma. 2 pi r means here perimeter of this droplet and sigma is the force here. So total force is equal to 2 pi r into sigma, that pi d into sigma here. So you can observe here surface tension. This. Because of the tension, it will attract molecules all towards inside. Equating the surface tension force, to the pressure force. So two forces, if we are equating, then you will get this formula. So delta P is the difference of the internal pressure and external pressure. So delta P will become to 2 sigma by R. So where R is the radius of the droplet and sigma is the surface tension. So delta P is the difference of internal pressure and external pressure. So here you can see it indicates the internal pressure in the droplet is greater than the external pressure. Here internal pressure is there and external pressure is there. So what he is telling here, internal pressure droplet is greater than. So what is this internal pressure and what is this external pressure? Here external pressure is the sigma. So that means surface tension. So it is nothing but it is acting toward the surface. The surface length is called 2 pi r. Okay, perimeter of that and sigma, the surface tension. So this is the external pressure. And internal pressure, what is the internal pressure? It should be more than the external pressure. Then only the bubble or this droplet will be in condition, stable condition. So internal pressure is nothing but due to the molecular attraction, intermolecular attraction. So the force due to the intermolecular attraction, that is the internal pressure, whereas the external pressure is the surface tension force. So the surface tension force is neglected in many engineering problems since it is very small. So you can see the practical application of this surface tension. So it is insect. So bud insect. So if it is with the legs, it can stand on the water because of the presence of the surface tension force, so that it will not sink into the water here. So references are this. So you can see this Subramaniam theory on applications in fluid mechanics, Tata McGraw-Hill's, and Modi and Seth hydraulics and fluid mechanics, standard book house. So today we learned the surface tension. It is nothing but the thin member under tension. Okay. The units for this is Newton per meter, the force per unit length. And why it is water droplet is spherical means because of the intermolecular forces. So the water molecule is nothing but the O and hydrogen, oxygen and hydrogen. So oxygen is having negative polarity. So it attracts the two hydrogens. It is becoming a molecule, water molecule. And these water molecules will have all the water molecules will have attraction between each other, so which is called intermolecular force. Okay, because of this force, the water will become a spherical in shape, intermolecular forces. So water molecules will be pulled towards inside the bulk of the liquid. So you can see here the forces between the molecules. This molecule will be attracted with other molecules, and at the top surface no molecules are there, so that it will form a horizontal 180 degrees force here. The surface tension is 180 degrees there. And because of this top surface, if a droplet is there, all the molecules will come to close towards inside, so that it will have roundish of the spherical shape. Small this liquid droplet will act as a small spherical balloons. So because of this molecular attraction and surface tension. The formula for this, the force is balanced by the pressure difference is the FdP is equal to pi r square delta P here. So here you can see, so sigma is there, surface tension, H is acting at the surface of the top surface of the droplet, and whereas inside pressure is pi r square into delta P there. So inside pressure and external pressure. So this is the surface tension force. So 2 pi r is the perimeter of that, and sigma is the surface tension force. So then you can get this difference of this. So delta P is the difference of pressure. So inside pressure minus outside pressure. Inside pressure is due to the intermolecular forces, and outside pressure is due to surface tension. So if you solve this, delta P is equal to 2 sigma by r, where sigma is the surface tension, r is the radius of the droplet, 2 times the surface tension divided by radius, which gives the difference of the pressures, inside pressure and outside pressure. So here inside pressure should be more than the external pressure. So inside, because these intermolecular forces should be more than the external pressure, that is the surface tension here. So that's why here the bug, with their legs, they can stand onto the surface of the water without sinking, because of this surface tension property of the water. These are the references Subramaniam and Modi said. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.